Hi, in this video lecture, we learn about variables. Variables are types of data. When you start a research, you have a certain idea. We call it as a concept. Once you get involved in that concept, you search for the related studies and to find some indicators. The indicators support your concept. So your concept is no more just a gut feeling idea, but an operational idea. Then you can take an action what you would like to investigate more. In order to investigate something, you need to set up questions. Designing a question is to find a variable. Variables should be something measurable. Let me take an example. You have an idea that smoke might cause cancer. You can find several indicators related with this idea. For example, smokers have more health problems. Then you plan your own study. You need to identify smokers and their health status. The possible questions may be the ratio of smokers of cancer patients, etc. Therefore, when you know what the variables are, your research plan is done. So defining the variable is extremely important. The variables are, or they should be, something measurable. The data type exists in different types. Each type has strength and limitation. Typically, there are 4 types. I'm going to explain you each of them in the next slides. Depending on the variable type, you have different choices of a statistical technique available. Therefore, how to define and design the variable is directly related to the entire research. Let's look into the type of variable. It's like a designing of a question. Suppose that you'd investigate whether any of your sample group are smokers. So you'd like to ask, do you smoke to your people? There are many different ways to ask people. How would you ask? I will give you 5 seconds to think about the question design. Did someone think like this? Do you smoke or did you smoke? And you ask people to pick yes or no. What about this question? Or what about this question? There is no correct nor incorrect answer. All are correct. But in this case, the answers will be either yes or no. You can code yes as 1, no as 2 when you give input in your Excel sheet or SPSS data sheet. But the numerical conversion, yes to 1 or no to 2, has no numerical interpretation. Like this question, nominal data are simply unordered groups or categories. Without order between the categories, you can say only that they are different. Smokers, non-smokers, they are different. But you cannot say one is better than the other or some are better than the others. For example, consider apples, oranges, and bananas. They are just different. No one fruit is inherently better than the other. What about the second question? The numbers from 1 to 5 are continuous data. And the differences between the measurements, so between 1 and 2, and 2 and 3, and 3 and 4, are meaningful. In a sense, it's meaningful in a sense that it represents an incremental increase or incremental decrease in perceived quality. But there is no natural zero. You can code from 0 to 4 instead from 1 to 5, but the 0 here has no meaning of a natural zero. And this question, if you have designed the question in this way, then you have chosen the interval type for the variable. And the last type, it is a ratio type. Ratio data are the same as the interval data with the addition of an absolute zero. With the ratio data, the differences between the measurements are interpreted as a ratio. Examples of a ratio data are age, height, and weight. In each example, 0 indicates the absence of age, height, or weight. So here 0 indicates 0 cigarette. And if you use SPSS, and if you have designed your question in such a way, then you give input like this. So first you create, this is data sheet and this is variable sheet. Smoker. Name of variable smoker. And I would convert yes answer to 1 and no answer to 2. So it's a number, and I don't need any decimal points. And if I put 1, then yes, it's add, and 2, no, and add. And here is just scale, and it's a nominal. It's nominal here. So as this diagram implies, each answer has a different belongs to different category. Okay, so here, if the first person answered yes, you see that 2 is directly converted to no, and so. But if you change here, and 1, 2, yes or no, right? Okay. So there are 4 types of variables. They are nominal type, hierarchical or ordinal type, interval type, ratio type. The nominal type differentiates between items or subjects based on their names or categories and other qualitative classifications they belong to. Secondly, the hierarchical or ordinal type ranks the item. The intervals between the measurements are not meaningful, which means if the items are ranked like 1, the first place, second place, and third place, and the fourth place, the intervals between these two and between these two are not meaningful. You cannot say that they have a double distance between or double intervals than this distance. Just their order is different. And the interval type allows for the degree of a difference between items. Typically, a Likert scale. Likert scale is if you ask like I hate it, I like it, and you have in-between steps, and your participants pick or tick one position here or there. So it's a scale of asking likelihood toward any direction. A Likert scale is a representative example, but there is no 0 point. And lastly, ratio type estimates the ratio between the magnitude of a continuous quantity. And the ratio type possesses absolute 0. For example, height, weight, age, and etc. Now you can link these questions to its type 4. In asking preference of these 5 beautiful dresses, you could design these 4 questions. And you can link whether this belongs to nominal type or hierarchical type or interval type or ratio type. You can make the connections, 4 connections, and the answer will be shared in a class. So now I hope you are very clear with the different types of variable. Once you are ready with the variable, you can think about the relationship between the variables now. Many of hypotheses include the relationship between the variables. Some are hypothesized as causes, while some are as a result, or some are as bias or covariance, which has influence to the result. The analysis focuses on whether the relationship has the statistical significance or not. Sometimes your hypotheses are supported, sometimes they are rejected. In some cases, you need to explore the relationship based on the statistical evidence. You conduct an empirical study involving many potential variables, and then later you form a relationship and suggest it as a model. In both cases, you need to identify both independent variables and dependent variables. Independent variable is an aspect that you manipulate or when it is decided and acts as a cause. And dependent variable is what happened as a result. So independent variable is the cause and dependent variable is the result. The cause and the result can be more than one. For example, 2 causes create one interaction, and this interaction influences the result, whereas none of 2 causes influences the result. It's also possible. Or one cause results more than one results at the same time. So in this case, one variable acts as independent variable, and the other variables, n2 and 3, they are all dependent variables. It's like when you drink too much, then you will gain weight, and your blood pressure will increase, and your stress level will also increase, and your grade will decrease, right? So it's all consequences bind together caused by one cause. So the cause and effect can be multiple. Also, the cause and effect can be exchangeable. The cause and result are not inherently assigned to any variables. You decide which variable acts as cause or result. In the first case, there are no independent variable nor dependent variable. Just 2 variables have a certain relationship. Since the donut intake and gained weight can be measurable in a continuous scale, such as interval type or ratio type, a correlation analysis should be proper to analyze the relationship or to quantify the relationship, the strength and the direction of the relationship. And the second And the third case, left ones are average, so they are causes, independent variables, and the right ones are dependent variables. In both cases, you can perform a regression analysis to predict a gained weight or to predict desired donut intake based on the donut intake or based on the gained weight. So the hypothesis in the second case is like if you eat too much donut or if you eat donut, then you will gain the weight. And the hypothesis of the third case is when you gain weight, then you are more appetite or you would like to eat more donuts as a consequence. Therefore, depending on how you define the relationship between variables, the applicable statistic techniques will be different and the procedure will be also different. Thank you for your attention and see you in a class.